Yeah.
All right, let's go then. Blair Dupree of Drive Tech helped me get into the car.
Protection. This is a nice thick helmet, huh?
And it's not so easy because there's no doors, okay? You have to kind of climb in through a window.
Bring your left foot up in there.
Okay.
Bring your right foot on up.
I feel like I'm breaking into a car. And then kind of slither your way in. Being in that race car was really exciting. When I was going around the turns, I could really feel the G-forces.
Ted, give you a good ride, didn't
Yeah, well, I'm glad Ted was the driver. I couldn't do this, you know? I was scared out of my seat, and I wasn't even the driver, okay?
With the car nicely warmed, a FLIR infrared camera, set up by thermal imaging expert Ross Overstreet, sees everything literally in a new light.
Hello, Allie. Ross, how are you doing?
Doing good. How are you doing?
Good, good. Let's look at these infrared images.
Right now we're pointed at the back of the car. The best way to think about it, it's more of a measurement device than a camera. It's like having a million different thermometers spread across the image. We're actually getting temperature measurements on each of those pixels. Things that are supposed to be hot look like they're glowing. They're red and orange and white. And things that are cold are colored blue and black, and colors you associate with cool objects.
Right.
And you'll notice there's several different hot areas of the vehicle.
Now, I see some variations across the tires.
Yeah, and you'll notice that the one tire is a little bit warmer than the other.
The right-hand tire was indeed hotter than the left-hand tire because there was more pressure on it during the turns. So how hot is that hotter tire there?
We made a measurement earlier of about 190 degrees Fahrenheit, almost the temperature of boiling water on the tires.
When we just look by eye, we can't tell whether something is hotter than something else, but here you can tell, and that's really cool.
Right, this camera would work just as well if it was pitch black or in the middle of the day. It doesn't care about solar light at all.
The infrared camera sees the racetrack the way the WISE survey scans the dark and faraway realms of our solar system. If Nemesis is out there, infrared should reveal it.
The hot spots of the race car are sort of like warm, glowing objects out in the cold depths of space, far from the sun. This is a whole new way of discovering objects. Objects too faint to be seen through a normal optical telescope, but bright enough to be detected in the infrared.
The WISE telescope completed its sky survey in early 2011. But in the search for Nemesis, the results are still inconclusive.
The WISE survey is going to take a long time to analyze, simply because there's a huge amount of data that had been gathered by this craft.
About half of the Nemesis candidates have not yet been studied, but in the next few years, we expect the theory will be either proven right or wrong. Until that time, it is and should be controversial.
That something so relatively near to Earth can be so obscure is what Frank Jankowski of Mobile, Alabama, wants to ask the universe. Why can scientists observe objects in space that are millions of light years away, yet have difficulty spotting objects at the edge of our own solar system?
That's an interesting question, Frank. The objects that are millions of light years away that astronomers can see are powerful and luminous. They produce a lot of energy on their own, like an exploding star. But an object near the edge of our solar system might be small, and it reflects only a little bit of sunlight, so we can't see it at visible wavelengths.
But as scientists analyze the data for signs of Nemesis, they have made a disturbing discovery. Although calculations indicate that Nemesis isn't due back for millions of years, something appears to be shaking up the comets in the Oort cloud right now. Could Nemesis already be upon us? Since the birth of the Nemesis hypothesis, astronomers have been on the lookout for a faint red star that periodically disturbs the gravitation of the Oort cloud comets. This sends them on a catastrophic rendezvous with the inner solar system, including Earth every 26 million years. But as scientists study the Oort cloud, they have uncovered unsettling evidence that something is disturbing comet orbits right now. Has Nemesis already returned?
If the sun was all by itself and there was no Nemesis, then the comets in the Oort cloud would all have very predictable and regular orbits. They would be very regular in their arrival times and departure times.
Without gravitational interference from anything other than the sun, Oort cloud comets, like juggled objects, could spread out evenly across the sky. However, that's not what some scientists report.
When we look out into the sky and look at where the comets are coming from, their directions tend to concentrate in a certain region of the sky. And one possible explanation for that is that that skew is being directed by the gravitational perturbations from an unseen object that is out there.
Based on these observations, scientists infer that a huge object is disturbing the Oort cloud. They do this the same way that California transit officials infer that an accident is disturbing traffic patterns in Los Angeles.
So Marco, where are we? What is this room?
Well, the map we have here on the wall, that's our freeway system map, and as you can see, it shows the major freeway routes in Los Angeles.
The green dots represent normal traffic flow, while the red dots indicate that something is causing traffic to back up.
So the speed here is just one indicator that something's going on, but to really know what's going on, you either have to have a camera or a report from somebody who's actually there and able to tell you what it is.
That's correct.
Astronomers have this problem all the time. They're trying to understand what they can't actually see. In astronomy, we frequently infer the existence of something not because we can actually see it, but because we can see the influence it has on the objects around it.
Whether too many cars are crowding too few lanes during rush hour, or an accident is slowing traffic flow, something causes congestion. Since scientists see similar congestion in the Oort cloud, could Nemesis be the perpetrator?
This place is very impressive. It's got all the cameras, all the sensor data, all the California Highway Patrol incident reports. This is far more data than astronomers have to work with. If we only had remote cameras all throughout the outskirts of the solar system, we might know a lot more about it.
Even without remote cameras, scientists have proposed a remarkable theory to explain the congestion in the Oort cloud. According to this theory, the culprit disturbing the Oort cloud isn't Nemesis. Instead, it's something equally astounding. A giant, undiscovered planet 4 times the mass of Jupiter. In short, the largest planet in the solar system. Scientists have proposed naming it Tyche.
In a nutshell, Tyche is Nemesis light. Nemesis, in the original hypothesis, was literally a red dwarf star, something that was 100 times more massive than Jupiter.
Unlike Nemesis, Tyche would not glow like a star. Instead, it would look like a strange version of Jupiter.
If you put on night vision goggles, then it would be quite a bit more impressive sight. You would see breaks in the clouds, and there would be lightning. You would see the clouds light up from the lightning down beneath the cloud tops.
Tyche may disturb the orbits of comets in the Oort cloud, but it can't be the source of Earth's periodic extinctions. First, its proposed position puts it on a 1 million year orbit, not 26 million like Nemesis. Second, it's too small.
Tyche doesn't really have the gravitational mojo to dislodge comets, send them crashing in these periodic extinctions, really rearrange the Oort cloud. And so its effects would be visible only in these small skews and not in the form of huge pulses of comets coming out of seemingly nowhere.
Just as with Nemesis, NASA's WISE survey should be able to detect Tyche if it exists. While it's surprising that our solar system might harbor a giant undiscovered planet, it doesn't support or refute the idea that it also harbors the undiscovered star Nemesis. But a recent finding in the outer solar system may shed more light on whether Nemesis really exists and the kind of threat it may pose to life on Earth. In 2003, astronomer Mike Brown made an historic discovery when he found something floating around the night sky he couldn't explain.
I remember the day that I discovered Sedna, looking at it on my computer screen, looking at these pictures, my first reaction was, that can't be